Hi everyone, and welcome back to Casper's dApp Developer Series. In today's video, we'll be writing session code that allows us to port the whitelist from the whitelist contract we made in the last video directly to a CEP-78 contract. This way, a user can apply, the administrator can select who to approve, and then can apply that whitelist to a deployed CEP-78 NFT collection. After which, whitelisted users will be authorized to mint from the NFT contract. We'll begin by writing the session code responsible for porting the whitelist. Open a terminal and navigate to the root directory of the project from the last video. Run cargo Casper update whitelist to create a new Casper project named update whitelist. Now open update whitelist /contract/src/main.rs in an editor of your choice. I'll be using VS Code. On line 12, add use alloc vec to add vector support. Then under Casper types, delete API error and add uref contract hash, runtime args, and the runtime args macro. And we'll get rid of key name and runtime arg name as we won't be needing these. Now delete everything in the call function. The call function is solely executed when we deploy the session code, so all of our logic will live here. We need to start by obtaining the contract hashes for both the whitelist contract from the last video and a CEP-78 contract. These values will be provided from the client as key objects, and we need to convert them into contract hash objects. We can do this by getting the argument as a key, converting it into a hash, mapping that hash to a new contract hash, and unwrapping the result. We'll do the same for the CEP-78 contract hash. Now, to acquire the actual whitelist from the whitelist contract, we need the uref of the vector that contains the whitelisted accounts. Before we can do this though, we need an entry point in the whitelist contract that will obtain this uref for us, so go ahead and open up the whitelist contract. Scroll down to the bottom and add a new function, getWhitelistUref. Inside this function, all we need to do is get the named key whitelist, convert it into a uref, and return it to the caller as a CL value. Then specify this new function as a public entry point in the call function, accepting no arguments. Finally, head up top and add CL value to Casper types. Head back to the update whitelist session code, and after obtaining the contract hashes, make a call to getWhitelistUref and enforce the return type as uref. Now that we have the whitelist uref, we can read the stored value as a vector of account hash strings. The CEP-78 contract expects the whitelist as a vector of keys though, so we need to convert this vector of strings. We can do this by converting the vector into an iterator, then mapping each account hash to the key from formatted string function. After mapping, we use the collect function to convert the iterator back into a collection, specifically a collection or vector of keys. Finally, we need to call the setVariables entry point on the CEP-78 contract. This entry point accepts runtime arguments consisting of either an updated whitelist or booleans specifying the changes made to CEP-78 modalities, or a combination of the two. In our case, we only wish to update the whitelist, so we only provide the argument ACL whitelist. Our session code is now complete. Let's quickly write a Node.js script to deploy an appropriate CEP-78 contract. Create a new file, deploy CEP-78.js in the root directory of your project, and open it in an editor. To make things simple and concise, we'll use the CEP-78 JS client, which we can install later using npm. Import the following classes and enums. We'll also need the keys class from the Casper JS SDK, and we'll import the CSPR to motes function to keep gas costs readable. First, instantiate a new CEP-78 client, providing a node URL and network name. Load in the secret key of the account you used to install the whitelist contract. Now we can install the CEP-78 contract. Call the install function on the newly created CEP-78 client. Here we provide the collection name, symbol, and token supply. We provide the ownership mode as transferable, the NFT kind as digital, the JSON schema is empty because we'll be using the CEP-78 metadata kind, the identifier mode is ordinal, counting up from 0, and the metadata mutability immutable. The minting mode is ACL, which is our whitelist mode, and the owner reverse lookup mode is disabled as it doesn't matter for our use case. For our gas costs, we've specified 250 CSPR or 250 billion motes. Our deploying account is keys.publicKey, and we provide the entire keys object so it may sign the deploy. Finally, we can send off the deploy and just log out the deploy hash. Now we can deploy our CEP-78 contract as well as our whitelist contract with the newly created entry point. To do this, head back to your terminal and first install the Casper.js SDK and Casper CEP-78 JS client npm packages. Now run node deploy CEP-78.js. We're getting an error because we can't use await at the top level, so let's wrap all this in a new asynchronous function deploy contract. Now call this function and head back to your terminal and rerun node deploy CEP-78.js. Copy the deploy hash and head over to cspr.live and paste it in. It succeeded, so if we head to the installing account and go to named keys, we should see the contract hash right here. Now let's reinstall the whitelist contract. Head back to your terminal and navigate into the whitelist directory, run make prepare, and then make build contract. Now redeploy by running /deploy.sh. Copy the deploy hash and head over to cspr.live, paste it in, and wait for it to complete. Now that it's succeeded, head over to the installing account, go to named keys, and we should see the contract hash here. Next, we'll make additions to the front-end dashboard from the last video. Start by opening up admin.jsx. We're going to need a way to apply the whitelist to the CEP-78 contract. Since the logic for doing so is contained in the session code, we need to obtain the compiled WASM binary from the backend. Head to the bottom and create a new asynchronous function getWASM that will get the WASM binary from the backend at the endpoint getWASM. The get request result will come in the form of an array buffer, which we'll want to cast to a uint8 array for installment of the binary. Now let's create a function to handle installation. Go ahead and copy the approve function and rename it to apply whitelist. Remove the candidate parameter as we won't be needing it. In a production application, you would likely want to break these functions down so as not to repeat code, but since this is an example, we won't bother with that at the moment. Go ahead and delete everything before the deployed JSON definition. At the top of the function, define the CEP-78 contract hash from your named keys. We need to convert this string to a CL byte array for use in our runtime arguments. We need to do the same for the whitelist contract, which is passed down through the props from app.js. The slice method is used to remove the hash hyphen prefix, and decode base 16 converts the hexadecimal string to a uint8 array. In building the runtime args, we need to convert the CL byte arrays to CL key values, which we can do with CL value builder. Note that these runtime arguments are the same that you'll find in the update whitelist session code. Next, we'll load in our WASM binary to a new variable WASM. Finally, let's build the deploy object. Use contract-client.install to create a WASM installation deploy, providing the WASM and arguments we created above. The remainder of the function below can stay the same. Now we need a way to initiate the apply whitelist function, so let's add a button at the end of the whitelist list in the admin panel. Lastly, we need the CL byte array class and decode base 16 function, and then we're done. One more thing we need to do on the front end is to update the whitelist contract hash in app.js. Head over to cspr.live and copy the whitelist contract hash. Head back over and paste it in here. All that's left is to create an express endpoint on our backend to serve the WASM at the getWASM endpoint. So open up server.js. Update the whitelist contract hash here as well. Head to the bottom and open up a new getEndpoint getWASM. And within this function, we'll simply read in the WASM binary, convert it to a uint8 array, and send it as a buffer to the client. To ensure the JSON deploy containing the WASM binary isn't too large, we'll increase the request body size limit in app.use express.json. We also need to import fs to be able to read the file. That's it for the backend. Let's now build the update whitelist session code. Head back to your terminal, move into update whitelist, run make prepare, and make build contract. We're getting an error because there's some leftover boilerplate code trying to use a class we don't have imported. Go ahead and get rid of this error handling code and recompile the session code. Now let's test our application. Head back to the terminal and navigate into the dashboard directory, then run npm install. Now run npm run start. Now head back to your terminal, open up a new tab, and run node server.js. Go back to your application and make sure in the Casper wallet that you're using an account that is not the installing account. Click Connect to Casper Wallet, select User, click Apply, sign the transaction, copy the deploy hash, head over to cspr.live and paste it in. Now that it's succeeded, head back to your application, click on the Casper wallet, select the installing account, refresh the page, click Connect to Casper Wallet, Admin, Candidates, and Approve. Copy the deploy hash and paste it in Casper Live. Once it's complete, we should be able to go back to our application, click on Whitelist, and apply whitelist. Sign the deploy, copy the hash, and paste it in. Our session code deployment succeeded, so we should now find that the whitelister's account hash is officially part of the CEP-78 contract's whitelist. Let's copy the account hash, head over to the installing account, named keys, whitelisted collection, let's go to its named keys, go to ACL whitelist, click on dictionary, paste in the value, fetch key value, we find that it's true. If we were to try another account hash, we'll find that the value is not found in the state. Our freshly deployed CEP-78 collection can now only be minted from by authorized whitelisters. You can use this functionality to create a dApp that requires users apply and are approved to access your collection. That's all for this video. Thanks for watching, and be sure to subscribe if you'd like to see new dApp Developer Series videos as they are released. I'll see you in the next video.